Let me go and record, but so I can upload it. Let me maybe start doing that now. So today, we're going to avoid graphs, okay? We're not going to graph. We're not going to use Desmos. We're not going to look at graphs or graph it ourselves. We're just going to look at the two equations, look at the system, and then we'll find what the solution is. And again, the solution is a point. Let me call it point P. The solution is, forget about P, just x1, y1, okay? When I use x1, y1, that just means it's two generic numbers. Two generic numbers like 0 and 0, or 2 and -5, or 10 and -9, or 1 and 5, you know? That one point is your solution, okay? So why say x1, y1? That's your generic. That's the format of the answer. There we go, okay? So, like I said, no graphing, okay? Because often I've said that graphing, or maybe I didn't say this, graphing is just a tool. Looking at the graph is a tool because we are creatures, we're visual creatures, okay? So we want to see what it looks like, but the visual representation of what's happening is just what? It's just a concession we human beings are given to the reality that's happening behind the scenes, okay? I'm sorry. What I'm trying to say is graphs are just visual tools. Algebra is all about the equations, the numbers, the variables. Algebra is all about equations and numbers. Graph is just a tool to help understand the equations. You know, a linear equation, it looks like a line, right? Not really. I mean, that's besides the point. When we graph it, it looks like a line. So that line on the graph helps us comprehend what's happening. What's up? Absolutely, go ahead. So let's do this example 1 right here, okay? And again, the method we're going to use to find the solution to the system is substitution, no graphing. So try to follow carefully, and I think I taught this well. We'll figure out how to teach it well last period, okay? So here we are, solve the system by substitution. That's what we're going to do, okay? So here's two, equations, both linear, okay? So we're not going to graph and find where they intersect. We're not doing that business anymore. Substitution is what we're going to do here, okay? So, do you need something, Emily? Oh, Donnie, I'm going to see him on Friday, right? Recording again. All right, so substitution, okay? So let's look at it. We got two linear equations, absolutely. Substitution, I didn't say what substitution means. Substitution means literally just plugging in. We've done that, okay? If I say x equals 2 and I tell you to plug in, you know what to do. You take 2, you find x, and you plug in 2, right? But since this is a system, there's two x's, aren't there? So if I tell you to plug, the value of x is 2, you're going to plug it in for both. And that's substitution. Plugging in is another easier word for substitution. And if I tell you y equals 11, you can go and plug in 11 for y. What do I mean by plug in? Erase y and then replace it with 11. Replace and plug in are the two ideas of substitution, okay? So look at it, y equals this. But also, y equals this. How interesting. Y is here and here. Those aren't two different y's. This is not two different scenarios. Y equals that and y equals that. Okay? Well, substitution means plugging in. So I'm going to plug in one equation into the other. That's how we do this, okay? One equation into the other. And what I'm going to do here is plug in this y right here. So y equals -x, right, according to the second equation. I'm going to take that second equation and plug it into the first one. Where do I plug in y into the first equation? Right here, right? See what happens, okay?
Does it matter which one you plug in?
No, but the easier one is the better one.
Yeah.
Just whatever you look at it, you analyze which one would be easier, and then go with that one. So plug in y. This is what I'm doing here. And I'll show some arrows representing that, okay? So this y goes into the first y up there. So what does that look like? I'm going to rewrite the first equation, okay? Actually, let me rewrite the first equation as it is up there. And then I'm going to plug in y. Boom, look at that. You see? Maybe this was extra stuff to write and I didn't need to write this, but I went ahead and wrote it so in the notes it makes as much sense as possible with as little, I'm trying to make as little work shown as possible. When you see the work and you can refer back to it, if I can make the amount of work as little as possible, but the points, the important points clear, I think that's the best strategy, okay? So first step is rewrite the equation, but plug in one equation to the other. So look at this second line here. Do you see how this is the first equation rewritten? Do you see the first equation here? You should, but what's different? This negative x. Why is there negative x here? Because I took this equation and rewrote the y with that. Boom. Okay? So now, what I'm going to say, I'm going to tell you to solve for x, okay? But I'm just going to do this. X equals 2. One second. All right. Do you see what I did? Like, I'm making as little work as possible, okay? But from here to here, it should be clear what happened. From step to step, what happened should be clear. See, I had this equation, okay? And then I solved for x. X is 2. Boom. That's the trick or the magic of substituting. I plugged in y, okay? And then I got rid of the y's. Once I plugged in y, then I have no more y's. Look at this equation. There's nothing but x's here. So combine the x's, solve for x. X is 2. Okay, so I skipped some steps. Why? Because I told you I'm trying to just get to the important points. All this extra stuff, that's like middle school stuff, let's skip it. Why make the notes so long and complicated or to follow unnecessarily? From step to step, it should be clear. And this is clear, I hope. X equals 2. How did I do that? I plugged in one equation into the other, okay? So next step is use x equals 2 to find y. Okay, why do we need to find x and y? Because the solution is a coordinate point. It's x comma y. x1 comma y1 is the solution, okay? So just because we found x doesn't mean we're done. We need to find the y when x is 2. We found one part, we need to find the other part. So if x equals 2, we need to find y. How do we do that? What we're going to do is take any one of those two equations and bring it down there. Which one do you think is the easier one? Second one is easier. So I'm going to take an arrow, bring it here. And I'm not going to rewrite that exact same equation. I'm going to get down to business. Tell me what I did here. From that step, we had this goal. I brought this down here. What did I do here? I did what? I plugged in x. X is 2. I plugged in. I rewrote this, but the only difference is x is 2, so I plugged it in. So what's the value of y? Y is negative 2, yes? Yikes. All right, so the solution is what? The solution is the point 2 comma negative 2, yes. Solution is the point 2 comma negative 2. I plug it in here, I type it in here, submit, I got my answer right. Okay, we found the solution. We did it without graphing. If we were graphing, we'd graph the two lines, find where they intersect, and we would find this exact answer, yo. But we did it algebraically, just using the numbers in the equations. All right? So let me do another one of these examples, and then another one after that. Here's we go. All right, we'll call this example 2. All right, first step is, I forgot, plug in y. First step is plug in y. So let's just take the second equation, plug it into the first one. That seems simple. So what I got is 2x equals negative 2x plus 16. So y'all can write along if you want or take a picture. whatever it is, you're responsible for the delta math, okay? The notes here are for you to, for me to introduce it, honestly. Whenever I show something, it's an introduction. I'm not showing you how to do it. You learn how to do it by practicing, getting answers wrong until you get it right. And you always get it right by making mistakes. That's the only way to learn, trying it and making mistakes, and then that's it. I talk here, it's just an introduction, okay? All right, so plug in y. Look right here, what did I rewrite? Is this the first or second equation?
First.
First, but what's the only thing that's different? The y.
Y.
This y of the second equation, I put it right here. Boom. So it should be clear. I'm going to avoid writing too many notes, too many words, too many steps. Let's just hope it's clear with as little stuff here as possible. All right. So look at this equation here. 2x equals negative 2x plus 16. I'm going to tell you this. This is true. X equals 4. From that equation, if you move stuff around, get x by itself, you find the value of x. It's 4. So that's good. That's half of the solution. So I'll put it right here. 4. But my solution is the xy coordinate point. So use x equals 4 to do what? To find y. Which is the easier equation that I could use to find y? The second one? So make an arrow, bringing it down here. I have y equals 2, but instead of rewriting x there, I'm going to plug in. X, what's the value of x? Is 4. So y equals 8, y'all. So I'm going to plug this into the coordinate point. 4, 8 is your answer. We found the x, we found the y. It's 4 and 8. That's the solution. So that point is the solution. So if we were going to graph these two lines, the intersection would be at this location. But we're not thinking visually or graphically or where it is in a piece of paper. This is all just equation, okay? Using the equations and the numbers and plugging in. And the fancy word for that is substitution, okay? I'll do one more. And y'all can work on the delta maths. Moving on. What happened here? What's going on? Next. It doesn't, does it? That's fine.
Can they hear us talk?
Who doesn't? Oh, them? I mean, no, that's not, I'm not streaming it. I'm just recording it.
Okay, so me cursing, no kids are right here. Listen back.
Hopefully not. All right, moving on. So last one, and then I'll get to work. Solve the system by substitution. Okay, let's look at this. We have a linear equation here. That's a fact. It's not in y equals mx plus b format, is it? Look at the first equation. It is not mx plus b format. That's fine. It doesn't have to be. We can change it to that if we want, especially for graphing. For graphing, mx plus b is ideal. And look at the second equation. That is not in y equals mx plus b format either. Y is not by itself, you see, for either of them. But that doesn't matter. It's still a linear equation. In fact, this would be technically called standard form. But whatever it is we're not going to let it stop us. We're not going to let this stop us. We're still going to plug in and find our numbers. Easy as pie. Okay? All right. So what should we do? Like I said, there's many ways to go about this. If you want, you may, you can. It's one way. Convert both to y equals, and then do this problem like the first two examples. You can do that. But I have an idea. I'm just going to solve the first one for y. I'm going to get the first one by itself, or get y by itself for the first one. So this equation, I'm going to say it y equals x minus 4, okay? And then this is what I'm going to do. I'm going to take that first equation, plug it into the y of the second equation. Okay, what does that look like? 10x plus 2y. But help me out. Instead of plugging in the letter y, what am I plugging in? X minus 4, okay? So boom, here we are.
You spelled
This is what? The second equation rewritten. Look, this is this equation here. Okay, I rewrote it. But instead of y, I erased y. And I put what y is over here. Y is also x minus 4. So if y is x minus 4, I can erase y and plug in x minus 4. Because they're both the same values. Equations. Y, get rid of it. I can write x minus 4 instead. And this is helpful. Why? Because look at it now. I have nothing. The only variable I have here is x. So I can find the value of x. And I have half the solution. So this 2 looks like it needs to distribute before we can do anything. But in the end, I'm going to skip all these steps. I believe it's x equals 2. I can't do that in my head, but this is what I remember from last period. Yes, so we have x equals 2, right? So find y
And then the conclusion
with x equals 2.
is 1,000.
So how do we do that in the other two examples? We took one of those initial starting equations, brought it down. I'll take the first one, because the first one is the easiest. I'm going to rewrite it, but I'm going to rewrite it with x as 2, because the value of x is 2. So y plus 4 equals 2. So that means y must be negative 2. Boom. So the solution is 2 comma
Gave up on actually.
negative 2.
Oh, joy. I see my shack.
That's how we do it.